Hello everybody, I'm Nick, and in this new video series called Cracking the .NET Coding Interview, I'm gonna start talking you through different test scenarios or questions or exercises that you might have to encounter when you're looking for your next job in .NET software engineering. Just a disclaimer, this is not about algorithm questions and binary trees and all that jazz. This is about practical examples that you will see in companies other than Microsoft, Google, Netflix, Amazon, and so on and so forth, which there are plenty of worth working for. You don't have to work in one of those huge companies that ask you to do algorithm tests. So we're focusing on that side of things, and we're going to see real examples, maybe a bit modified, from tests that I've personally taken in the past and you might actually take in the future. In this first video, I'm going to show you the first part of the refactoring test, which is a test where the interviewer is sending you a test and asks you to perform refactoring on a legacy application. This test usually try to check for your ability to identify code smells and apply patterns such as solid, things like kiss, yagni, and dry. And I'm going to talk you through everything about how I'm thinking when I'm tackling such a problem. I have both the raw code of the test in case you want to take it before you see any of the video, but also the edited version as I'm working through these videos in the description for my Patreons. So if you're interested in using that, please click the link in the description down below. If that's something you like and you want to see more, please subscribe and ring the bell as well so you don't miss any future videos. So let's dive straight into the problem. So usually these tests are given to you with a code base and a description. This is the refactoring test in C#. You might have seen this in a few places. I know multiple companies that use a variation of this. And it looks like this. You are asked to perform refactoring on a specific class. And for example, in this scenario, it is the add user method. Assume that the code is sound in terms of business logic, so don't question the business logic at all, and only focus on applying clean code principles. Keep in mind acronyms such as solid, kiss, dry, and yagni. Try to keep it less than 2 hours, and I'm going to talk about this. Try to keep it less than 2 hours because it's very important. If you exceed the 2-hour mark, then leave comments on how or what would you do given you had more time. That's the main idea behind it. And then usually these interviews set a limitation or a bunch of limitations. For example, in this scenario, you cannot change the program.cs class, which is this class. You can change nothing about this, including the using statements. You cannot change namespaces. You cannot change anything. So it's effectively a harness class for you to know where you're heading and that you didn't actually break anything, because this is presumably part of a bigger system. And then you have another limitation, which is in the user data access class in the legacy app. You cannot change this class from being static and this method from being static as well. So these are the two limitations: no change in the program.cs and effectively no change in this class either. So what I want to do before I dive into anything is I like taking a look at every single class of the code base to see how the thing goes. And usually I start from the class that I am asked to refactor. In this scenario, it's the user service class. It's this class over here. And it's just a regular class with a single method called add user and a bunch of other things. There are a few things I'm already detecting. For example, we have some request validation here. Another thing I'm seeing is we're using datetime now. I get an offset for the age. I'll explain why this is a bit of a code smell in a second. And then we're newing up a repository here, and we're getting a client based on their ID. Now we have some checks based on the client name. So whether it's a very important client, or else just a regular client, we are applying, from what I can see, a credit limit. So presumably how much money this person can spend. And then if you have it or you don't have it, we're calling another service, the get credit limit service, to get what the value is for that user. And then at the end, we have some other validation based on whether you have sufficient limit and credit. And then we're adding the user into the database. So it's a series of things, and there's many things you might have thought of being wrong already. In this first part of the video, I'm going to talk about identifying those issues and how I approach dealing with those types of refactorings before I actually dive into the meat of refactoring this class. And I think the first bit is equally as important as the second, which is the actual refactoring. So every time I'm given something that is legacy to refactor, the first thing that comes into mind is unit tests. In fact, the description of this test is demanding you to have at least one test that validates the happy path. So the path where you actually have a user created successfully. Now, whether the test asks me to do this or not, I would definitely add unit tests to ensure that the refactoring that I'm going to apply doesn't actually break the existing logic, because I cannot run this program.cs to see whether it works or not for two reasons. First, the client repository, as we can see here, is using some sort of database store procedure, which we do not have access to. Same goes for the user data access. It uses some store procedure here as well with some parameters, and we don't have any context of the database that this will act upon, and we don't have a backup. We're not given anything. We're just given the app. And the other thing is the user credit service, and some of you that only recently picked up .NET might not know about this. This is a generated WCF client created by a WSDL file. So you really can't change any of this code because this is all generated code. So with generated code, you don't want to be touching it. There's a reason why it's made like this. You are not supposed to touch it. So this class is also off limits, including everything around it, but we can still use it. So with those two things out of the way, right? An API call that we can't actually make because we don't have an actual endpoint, and two database calls. How can we test this? Well, we need to make this class testable. And this is the first step, not only of refactoring, because some of the things we're going to refactor to make it testable will address some things like dependency injection being applied here to invert the control of the dependencies, but also it will ensure, as we're working on this, that when we in the next part of the video refactor this class, we didn't break anything. Because if I give this test back and I change the logic and they check it, I failed. So let's see how we can make this class testable first. Now there's a few things I would do. First, we have this iClient repository, which we new up on every request. Now, whether this needs to be newed up on every request or not doesn't really matter. These are things you can eventually communicate to the interviewer when they call you back, or you can put in the comments. But we don't really want to have something being called directly like this. In fact, before I do any refactoring on that class or any change, I want to create, I think, 3 folders. I have client, user, client status. These are models. And actually, a bit of a heads up, I'm not going to go over the top and split those to domain and DTOs for the database. Instead, I'm going to assume it's one type of model. You have to be pragmatic with your refactoring. So instead, I'm just going to classify them as models, and I'm going to put them in a models folder. And I'm going to update the namespace here on this folder. Here we go. Then I have a repositories folder. Here we go. I'm going to stick that in there as well. Then I will have a service folder, so services, but I will not move the user service to put it here because it will change the namespace, and the namespace name will change the using statement here, and we don't want to do this. If you did, you'd actually fail the test. So that service stays there. This one goes here, and then the user data access can go in a new folder called data access. So just a bit of organization on the files here. Let's just fix the namespaces for this project. Here we go. Nothing changed in our program.cs. If it was a change, it would be blue, and I would stop right there to address it. So now we're going to start trying to see how we can make this method and this class testable. There's 4 things I need to address. Datetime now. Client repository, newing it up every time in the method. the using statement and the user credit service, which is the WCF client, and then the user data access add user, which are all hardwired static or nude app classes that we cannot test this class without actually removing and addressing. So let's start with the simpler one. They're very smart with this test because they tell you that your age is represented by your birthday minus today, which makes sense. But if you want to test scenarios and write tests that don't expire, an expired test is something, for example, that I can use my date now as a parameter, but given the fact that I have a datetime now in the method, as the time goes by, this test eventually might fail because it might exceed the threshold or the limit of the age. Or instead of failing, it might pass because I was 21 and now I'm 22. So the test that was passing, now it's failing. So what we do usually, instead of doing datetime now, besides the fact that you would probably use an offset or a UTC here, is we have a datetime provider. So I'll create an datetime provider interface. And yes, please add this everywhere. And I'm going to create a property, which is a getter only property. And I'm going to have a datetime type, and I'm going to call it datetime now. And I'm going to remove the setter, so it's a getter only property. And then I'm going to create an implementation for that. And I'm going to call that datetime provider, which implements the datetime provider. And for the default one, I'm just going to say datetime now. So every time I call it, I'm getting the datetime now. Cool. So the first thing I'm doing now is I'm going here and I say private read only datetime provider. And instead of using datetime now, I will use datetime now through the provider. Why did I do this? I did this because through the interface, this getter only property is mockable. In my unit tests, I can go back and say this datetime is February 2021, and it will be that forever. So my test, no matter what age it is in the future or year it is, they will always be deterministic and always return the exact same result. That's very important. Many people get this wrong, so keep that in mind. It shows that you actually understand stability in unit testing as well. Now the other thing is the client repository. So if we go to this reference, what I want to do is I want to create an interface because I don't want to actually call any database here. I want to be able to mock this. So what do? I go into repositories and I create an interface for that. Client repository, and I'm sticking that method here and I'm adding that, and here we go. And now I'm making this implement the client repository. I did not want to do this. That's what I want to do. And now we can go back to the user service and add the private read only client repository. There's a reason why I'm not initializing those, by the way, yet. I'm going to do that in a second. First, I want to create interfaces for anything that should be mocked before I write my unit test to guard it. So with that here, I'm going to go ahead and delete that. And in case an interviewer asks, well, what if as part of the newing app of the client repository, we had some initialization logic? I mean, it's very unlikely that they're going to ask because it doesn't make sense to create a repository every single time. But if they did, then you could, instead of injecting a repository, assuming you don't have a DI container, which you should have, but assuming you don't have, you could create a function that returns the client repository and then describe how you want to do this, and then you can initialize it every time you want it, and this will create a new client. There's a stretch, so even if you didn't get exactly what I meant by all that I just said, don't worry, it's very unlikely that this will be brought up. So now the client repository is also mocked. What else? Oh, the iService client. Now the the user credit service client. So now this client already has an interface. It's the iUser credit service. The problem is that client base is disposable while iUser service is not, and we can't really change generated code. That's a big no-no. Never change generated code, because the next time you regenerate it, you're going to lose all the changes. So what do we do instead? Well, I'm just going to use the interface that the client has. So I user credit service, and instead of using a using statement here, I'm just gonna remove it and use a single instance. Again, if there's a very specific reason why this should not be, or this should be newed up every single time, then you can talk with the interviewer. But realistically, like what this will do, create a new HTTP client every single time behind the scenes, it doesn't really make sense. So not only it's more testable, but it's also more efficient. So for that reason, I'm gonna delete that. And now this part is also mockable. And the last thing is the user data access class. This is the class which is static. Now, obviously, because it's a static class which we cannot change due to a rule in the rule set, and same goes for the add user, we have to use it, but we can't test it because you cannot stick an interface here, right? If I tried, it will say make the class non-static. So how can we do this? Many people get this wrong. The way you want to approach this is you want to create an interface and a proxy class, and the proxy class will call the static method, but it's still mockable through the interface. I'll give you an example. So I'm going to create in the data access a new interface, and I'm going to call it user data access. And I'm also going to create, let me grab that name, a new class called user data access proxy. And I'm going to get that proxy to implement the user data access. And in that class, I'm going to just add an add user exactly as it is in that static method. That's not what I wanted to do. That's exactly what I want to do. And I'm going to implement it. Okay, so now we have the interface with the same method, which we cannot use directly on the user data class because it's static, but we can do this. And now, through a proxy class, we effectively solved the static problem, because now what I can do is I can go back into my user class and I can say private read-only data user class, bada bing, bada boom, and now my whole method is testable. So once you have everything testable, you want to start writing your unit tests, and you want to fully cover every scenario that this class or this method is dealing with. Not just the happy path. Don't fall into this trap. You really want to make sure that there's nothing you missed, because when you're refactoring, you break the logic, you're done. There's no, oh, he missed that, or they missed that. It's very, very important. So I left these uninitialized for a reason. Usually, if you want to have this be mockable, you would initialize them from the constructor, right? So if I make this like this, it will look something like this, right? You're going to have your interfaces being injected through the constructor, then you'd have some mocking, and that should be it. But remember that we cannot change the program.cs. So now this doesn't compile. What do? Well, the fix is actually quite simple. You can have multiple constructors, of course. So you want to create a different constructor that is parameterless. I actually said that word without having to do a second take. This is amazing. And then you say this, and this is where you initialize the other constructor with all the default values. And now you have two constructors, one which is expecting the interfaces, and another one which is calling the other one that's expecting the interfaces with default implementations, which means our program won't break, but also that we can now write unit tests. So that was the first step of the whole refactoring process. I like to call this the setup. And it's a prerequisite for you to know that what you're going to change is guarded. What we have here is a few things. We have a name, first name and last name check, whether it's null or empty. a very dumb email check that is not actually checking for an email. Kind of is, but not really. If you think about it, this is wrong, but we cannot change it. Remember this business logic. You might fall into the trap of changing it and fixing it, but you just broke the consumer because you're not consuming in the exact same way. So be careful with that. Then we have some limitation, the age of the user. So less than 21, you cannot use the service. And then you have some stuff here. This is a very obvious open close violation, because every time you want to add a new client name, you have to edit this. But still, based on the name, you have some sort of credit change. So if you're a very important client, you don't have any credit limit. If you're an important client, you have a credit limit, but it's double the normal limit. And if you are a regular Joe, then you have a credit limit, and the credit limit you get from the service is that. Then if you have a limit and the limit is less than 500, whatever that means, then you cannot be created in the system. And then once that all is done, you can get created in the system. And this is where the unit testing starts. And I'm going to create a new project here, and I'm going to call it refactoring test.unit tests. And I'm going to use XUnit for that, and then a few other packages for this unit testing exercise. Let me delete that. Okay, so the first package I always add is an substitute. It's my favorite mocking application. We have a video in the channel, top right corner of your screen, to check that if you want. Auto fixture, I think I'm going to add that. I don't know if I'm going to end up using it, but I think I want it there. It will allow me to create objects, fake objects, very easily. And then I also want to add fluent assertions, because it's just making asserting so much better than the assert dot whatever. So I think I'm going to start with these packages. The other thing I like doing when I have unit tests is Rider has this panel here with the unit tests, which now they have made my font so big so you can see it. Looks huge, but once we have tests, every time I save, it will automatically run those tests and tell me whether I broke something or not. So I'm going to show you how this works in a second. The test demands from us to actually write at least one test, which is the happy path, where the user is successfully created. And for that to happen, we need a valid first name, last name, email, date of birth that is more than 21 years old, a name other than a very important client or whatever, even though that doesn't really matter, and a credit limit which is more than 500. So let's go ahead and create a test class, and this is exactly how I would normally do it. I would go ahead and create a new class, and the way I name my test classes is the name of the class that I'm about to write unit tests for, and then I'm putting a test at the end. And then the way I'm naming my methods when it comes down to testing is the method that I'm testing from that class. So in that scenario, it would be the add user method, and then should do something underscore when something happens. And that's how I go about it. That's the skeleton. And I also use AAA, arrange, act, assert, to separate the setup from the action, from the assertion in my test. I don't think it's necessary. And I've actually been entertaining the idea of removing it because I think it's clear what is what, but it does give structure in your unit tests. So for the purpose of this video, I'm actually going to keep it here. So with that out of the way, what we want to say is that add user should create user when all parameters are valid. Just a very general statement, right? We want to create the user, we want to actually get the user validated. No fair. I'm gonna fact here, and then the way I start this is I usually have a private read-only, and then the class I want to test, which is user service, and I need to refer to the project. And then I usually, when I'm writing unit tests, the class that I'm testing, I call it a system under test, and I just put it like as an SUT to differentiate it from all of the others, which will normally have names when I'm initializing them. And I have a constructor here, and then SUT equals a new service, and I'm passing in the mocks. So what do I need? Well, first I need a date time provider. So private read only I date time provider equals substitute dot for the date time provider. And this is how I'm creating a mock. Then I'm gonna do the same for all the others. So what do I have? I have an I client repository. What was the other one? I user data access. Yeah, sure. And last but certainly not least, I user credit service. So we have all the classes now. And what I'm gonna do is provide them. So you, and you. And now we're ready to use the system and the test with all the mocked things. So now I need to see exactly what I want to mock, right? So I definitely need to mock the datetime now method to provide a deterministic date. So in the arrange thing, I'm going to say underscore datetime provider, datetime now returns, and I'm going to say what I want returned. So let's say new datetime 2021 02, actually just 2, comma 16, and this is just the 16th of February 2021. So this getter will always return the same value, and this will help us ensure that the offset that is being used when we calculate the age of the user is deterministic. Then what I want to mock is the get client by ID. So in order to do that, I'm going to say client repository dot get user by ID, client ID, and then I'm going to have a const int client ID here equals 1, and I'm going to say that this returns, and then I'm going to create a client, and for the client I'm going to use auto fixture. So I'm going to say private read only I fixture, here you go, equals new fixture. There we go, and we're going to use that. So of our client equals fixture dot build client, and the reason why I'm using build instead of create directly is because I want to make sure that the client ID used in the actual client class is the same that will be used later for the call. So I'm going to say do c dot client ID, which is the ID, is client ID. Well, that's definitely not do, this is with, my bad. So now the client ID will be that. I mean, the client class really only has 3 properties, so I could technically just create a specific client, but it's fine, let's use auto fixture instead, and we're going to return that client for that call. So 2 out of 4 things are now mocked. What is the next thing? So next thing is the client name, and since we randomize that through auto fixture, it's gonna fall here. So we wanna get credit limit, and get credit limit should return a number bigger than 500. So I'm just gonna say bada bing bada boom, here you go, get credit limit. The first name, do I have one created? I do not. So const string first name equals Nick, and then same thing for last name, and then var date of birth equals new date time, and I need to be more than 21. Well, that's not hard because I am 27 anyway. Wow, that's an old one. Okay, I'm gonna put a fake one here. Cool. So now I have first name, last name, and date of birth. And what we're going to say is we're going to say that this, let me just move this up, returns 600, so something more than 500. And the last thing is the add user call, which we don't really have to do anything with. We are going to validate against it though. So we want to make sure that it was at least called once, and we don't need to really validate any properties in this scenario. The last thing we want to validate is the result. So in the action, I'm going to say result equals system under test dot add user, and then I'm going to use the first name, the last name, the email, which is Chapsas@gmail.com, and then the date of birth, and then the client ID, which is the client ID. Here you go. And now in the end, I'm going to say result dot should be true. So we should successfully have created the user. And also, I want to say that the user data access received one call on the add user with arg any user. I don't really want to do any validation on that. So I'm going to say just anything that called it with any user at least once, or actually exactly once. And now I have the happy path scenario test that they wanted. I'll go to my unit test. My unit test is detected. So I'm going to run it. Here you go. The test is passing. So we are actually following the flow. I'm going to do two things. First, I'm going to enable continuous testing. So every time I save, unit tests will run. And the other thing I want to do is I'm going to cover my tests. And by covering, I will be able, let me close that now. I will be able to show you here that these green icons in the screen show the lines that the tests are currently covering. That doesn't mean they're covering everything about them. It means that test goes through that line and it touches upon it. So I still need to check a very important client is called. I still need to check important client is called. I need to check whether the credit limit is less than 500. So I have quite a few cases that I also need to handle. Now, for the sake of economy of time, I will show you the result of me writing those tests. There's nothing magic about it. I'm just going to write a bunch of tests that check, the first name is not empty, that the email is the way they expected, the age is more than 21, and so on and so forth. And I'm going to then talk you quickly through the tests. So I just wrote a bunch of tests. I want to talk you through them real quick. I've created a theory that checks for all the initial very common validation issues. For example, first name is empty, last name is empty, email is not an email, and age is less than 21. So I have checks in this inline data theory through that. If you don't know what this is, I have videos on unit testing. You can check that in the dedicated video. I don't want to stand too much on how I'm writing unit tests on this. And then I'm checking things like the correct credit limit is used when it's exceeding 500 or when it's less than 500. And at the end, I'm also checking things like the limit is less than 500 if you have a limitation on the credit. So if you see, if I run these tests, they all are passing. And if I cover them, again, all are passing. And if you see now the class, every single one of those lines are covered. And not only they're covered, both good and bad scenarios, like everything about this method now is set in stone. And only now I'm able to start talking about, okay, there's some code smells in here. I need to address them. This first part, this first 35-40 minutes that it took me to introduce you to this test is crucial, because anything that breaks this logic means you fail the test. In the next video, we're going to see how we can apply solid principles in this method and optimize it, make it clean, and put responsibilities where they should be. So just stay tuned for that. That's all I had for you for this video. Thank you very much for watching. Special thanks to my Patreons for making these videos possible. If you want to support me as well, you're going to find the link in the description down below. Leave a like if you like this video, subscribe for more content like this, and ring the bell as well. And I'll see you in the next video. Keep coding.